Good morning, good afternoon, or good evening, whichever time it is that you're watching this video. Welcome to session 3. Our review today is going to be sequences and average rate of change. Now, we discovered that sequences were a little bit challenging, but if we remember that really we're just dealing with y equals mx plus b or y equals ab to the x, it's not really difficult. The challenging thing with these three problems, or with these three types of things, are the notations. The notations, a sub 1 means first term, a sub 2 means second term, a sub n is any term, whatever term we're looking for. And just remember, this one is kind of important. A sub n minus 1 is the previous term. Anytime you see n minus 1, you know it's the previous term when it's hooked to an A. Now, arithmetic sequences or arithmetic sequences, remember we have this really strange looking formula where when we substitute it in, we got something that looked a little bit better. A sub n equals 4n minus 1. Remember, this really is just y equals mx plus b. That's really all it is. A sub n and y can be interchanged, as well as n and x can be interchanged. Arithmetic sequences or arithmetic sequences is when there's an adding pattern each time, and we're going to see that in just a second. Geometric sequences are when you multiply by something. This would be an exponential graph. It'll have an exponent that has an x with it. Now, we have to be careful because the explicit formula is really n minus 1. But in this particular case, recursive, remember, means the previous term and then what the common ratio is. So in this particular case, the previous term is 3 and you're multiplying by 3. That would be how you come up with your original equation. Now remember, the A is the y-intercept, so we'd actually have to go back one more, so it would be 1. And then it would be 3 to the x, 1 times 3 to the x, because remember, we're looking for the y-intercept. So in this particular case, we actually have to go backwards 1. So instead of multiplying by 3, we'll divide by 3. 1 times 3 is 3. So this equation for this particular problem would be a sub n, and I'll see if I can do this fairly quickly, a sub n equals, and then the y-intercept is 1, and then it would be times the growth rate, which in fact is 3, and then it would be to the exponent of x. An example of an arithmetic sequence is an example that was taken directly from the Regents exam in January of this year. Says in 2014, the cost to mail a letter was 49 cents for up to 1 ounce. Every additional ounce is 21 cents, which recursive function, so immediately recursive, you need to be thinking n minus 1, and notice that all of these have n minus 1 in them. So which recursive function could be used to determine the cost of a 3-ounce letter? So first of all, every time you see recursive, set up a table. Remember, we did a table where we would do, I'm going to do this horizontally just because right now it's going to be much easier if I do this horizontally so that you can see it. It'll be faster. So for 1 ounce, it's 49 cents. Sorry, for 1 ounce, it's 49 cents. For 2 ounces, we're not looking for 2. We're looking for a 3-ounce letter. So we make the table. When we do that, our y value, for 1 ounce, it's 49 cents. For 2 ounces, it's another 21 cents. So it's going to be plus 21. For 2, it's going to be plus 21, or in this case, 70 cents. So for 3, it's going to be the 70 cents plus another 21 cents for that extra ounce. So the third term is actually going to be 91. Hopefully I added that well. You guys know my adding skills sometimes. In this particular case, this would be what our table would look like. The first term is 49. The second term is the previous term plus 21 because it's an extra ounce. The third term is the previous term plus 21 because it's another extra ounce. In this case, if we take a look, choice 1 tells us the first term is 49 cents. That's how much the first stamp is. And then we have the first term, or the equation. Oh, I'm trying to draw. I'm not a very good artist with this arrow. But we have the previous term plus another 21 cents every time that you add an ounce to that. So the answer choice is choice 1. The second part of our review today is rate of change. Remember, average rate of change and slope mean the same thing. There's a whole bunch of information in these two boxes. We can find the rate of change with separate, this is actually a piecewise function. See, there's a purple graph, a green graph, and a pink graph. If we want the rate of change between this point and this point, it ends at 1,150 on the y-axis. Remember, slope is change in y over change in x. And then the x values are 1 and 0. This one worked backwards. So we can find rates of change just by finding slope. Remember that delta, or that triangle right there, means change. Whenever you're looking for the rate of change, and we see this often, it'll say rate of change from x equals 0 to x equals 1. In order to find that rate of change, you have to have a y value that goes with it. So if x is 0, in this case, y is 6. So we have that point, 0, 6. If x is 1, then y is 9. So we have that point. Then we go ahead and we do the change in y over change in x. You can't find average rate of change unless you have an x value and a y value, an x value and a y value. So these are some examples. Again, pause the video if you need to. I have one more example to hit. Also, there's just another, all these are different ways to write how to find slope or rate of change. And then the last example, oh my, it disappeared. Let me see if I can move it back up there a little bit. There we go. This came directly from a Regents exam. Again, I believe the one in January. It says a family is traveling from their home to a vacation resort, and they make a table. At 0 hours away, they're 0 miles from home. 2 hours away, they're 140 miles from home. 5 hours away, etc., etc. And so they want to know the average rate of change. So again, please remember it's from 2 and 7. So we have to create the points. 2 and 140. So the x value is 2, the y value is 140. The x value is 7, the y value is 480. That's how we find the slope. Then you plug in y2 minus y1. Now the order doesn't matter as long as you're consistent. This person did the 7 first and then the 2. But it's totally up to you. When you go through and you do that, then it becomes straight calculator work. Please make sure that it says including units. So if you had 68, but you didn't put miles per hour, you would not get full credit. Please make sure you read the directions. Average rate of change is slope. Between the hours of 2 and 7, find the points. And make sure you include those units. Have a great day.